Newton's first law explains how an object in motion tends to stay in motion, and an object at rest stays at rest. To simplify, we often just call it the law of inertia, the resistance of any physical object to any change in its state of motion. Maddie leans down to pick up the ball. Its inertia, mass, speed, and direction gets affected. She has provided an unbalanced force. Two forces acting on an object are not equal in size onto the ball, which causes it to stop moving as she picks it up. As the ball is resting in Maddie's hand, it is now again in Newton's first law, and all the forces are balanced. If Maddie was not there to stop the ball, in a frictionless world, it would continue to roll until the frictional force of the ball on the floor and the floor on the ball caused the ball to stop moving. The frictional force of the leather that is covering the ball and the wax gem floor would act on each other until the ball decreased in speed and stopped moving.
Here's the curling stone. It's going down the ice because of its mass times its acceleration equals its force, which the thrower acts upon it, and here it goes, and the collateral. Here we'll see Bob Johnson going down the ice. It's looking good. It seems that gravity's holding that stone to the ground. And here the positive acceleration is adding to the velocity, the perfect amount, and there it's good, and it's out! As gravity holds the stone down, positive acceleration increases the velocity of the stone, making it glide on the ice.
As the player swings the driver at the golf ball, the club exerts a force on the ball to launch it into the air. But, did you know the ball exerts a force back on the club? In fact, it exerts an equal and opposite force. This is known as Newton's third law. You might ask, why does the ball go flying if it's exerting an equal force on the club? Well, that's because the ball has less mass. The driver not only has its own mass, but the acceleration at which the player swings the driver at the ball. Golf also has a good example of projectile motion. A projectile is an object upon which the only force acting is gravity. Gravity and the angle at which the projectile is initially thrown dictate the trajectory on which it travels. Here, the golf ball is hit at a slightly upward angle. First, gravity must slow the ball's upward motion to a halt, i.e., negatively accelerating it, and then accelerate the ball positively towards the ground. If the ball were to be launched horizontally by a cannon, such as in this picture, then gravity would not have to slow its upward motion first. In addition, gravity accelerates objects toward the Earth at a constant rate, that is, 9.8 milliseconds squared. This is why if another ball were to be dropped at the same time, the other would shot. Both would land at the same time.